Okay, we are now combining sections 4.3 through 4.6, discussing triangle congruence using shortcuts, which is side, 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 angle, 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 side, and HL, which is hypotenuse leg. So, the learning targets, as can be seen here, I can determine if two triangles are congruent by side, 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 angle, hypotenuse leg, angle, and angle, angle, side. So again, we have some shortcuts here to be able to say whether two triangles are congruent. We're going to get in here and take a look at this. The first of these shortcuts to show that two triangles are congruent is side, side, side. So if you have two triangles, and we're talking about two triangles here, so two triangles, if three pairs of corresponding sides are congruent, then the triangles are congruent. The triangles are congruent. So visibly what this means is if I have one triangle here that looks kind of like that, and I have another one that looks basically identical, and let's put some sides on here, indicate that they're exactly the same. This is the same as this. This one is the same as this one. And this one is the same as this one. Then we know that the two triangles have to be congruent. This is side, side, side. Okay? So there's only one triangle that you can make with three sides of a figure. Okay? So side, side, side is one of our shortcuts to say, if I know that three sides of one triangle match three sides of the other, then I know that all of the corresponding angles are also congruent. All right. Next, we have a definition here, an included angle. An included angle is a definition. The definition of that is an angle that is between two given sides. So, as a picture, if we draw a triangle here. Oh, let's try that again. If we draw a triangle here. Oh, that's not a triangle either. We'll try one more time. Sorry. Okay, we have a triangle. And if I know this side and this side, then the included angle would be this angle right here. That is the included angle. This angle would not be an included angle. So we are saying that the included angle is the angle between two sides that we know. An included side is very much the same. An included side here is a side that is between two given angles. So again, if we take our picture of a triangle, and this time I say I know some angles. I know this angle and I know this angle. Then this side right here would be the included side. So, not this one or not that one. Okay? So, an included side is between two angles that you know. An included angle is between two sides that we know. All right, so those are just definitions. The next shortcut that we have is called side angle side, or SAS, S-A-S. So in a triangle, if two sides and the included angles are congruent to the corresponding sides and included angle in another triangle, then the triangles are congruent. The triangles are congruent. So visibly what this means is that if we have one side here and another side here, and we know that this is the side and this angle, then this third side, you can only have one side that'll make that work. There's only one angle that will work here. There's only one angle that will work there. So these sides here, so this green side as I put it in here, even if we're not given that side, there's only one side that can connect the other two. And if we look at these angles, there's only one angle that'll work here, and there's only one angle that'll work there. So those green angles and that green side have to be that way if we know that the two blue sides and the blue angle are what they say they are. Okay, so this is side, angle, side. Again, the angle has to be the included angle. Included angle. So if we have side, angle, side, then there's only one triangle that you can make, which means that any triangle that has side, angle, side matching between two means those triangles are congruent. Okay? Another shortcut that we have is angle, side, angle. Angle, side, angle congruence says that if we have a triangle, if two angles and their included side are congruent to the corresponding angles in the included side in another one, then the triangles are congruent. Then the triangles are congruent. So what this looks like is we have an angle, a side, and another angle. So this angle is fixed. We know what this one is. We know this side, and we know this angle here. So this is a second angle. So this is angle, side, angle. And if we take this angle and we extend it out, so I'm drawing this out green, and I take this one here and I draw this out green, there is only one point that we can find right here where this is going to make a triangle. So this length here is going to be fixed. This length here is going to be fixed, and this angle here is going to be fixed. And what I mean by that is that there's only one side, one angle and another side that's going to make this an actual triangle. And so by knowing the angle, the side, and the angle that we have in blue, that guarantees that there's a single triangle that works with. If we have angle, side, angle, then any other triangle with that same angle, side, angle has to be congruent to it. Okay? Another shortcut here, we have angle, angle, side. So in a triangle, if two angles and the non-included side are congruent to two corresponding angles and the non-included side, then the triangles are congruent. Are congruent. Okay, so again, let's take a look at what this picture looks like. So we have an angle. So this angle right here. We have another angle. So there's the angle, angle. And then let's say we have another side here. So we have angle, angle, and then side. Okay, so let's chop that off here. Angle, angle, and then side. Okay, so angle, angle, side means that if we take this side, we don't know how long it is right now, but because this has to make a triangle, there's only one point that's going to work for that. So there's only one point where that green line is going to make a triangle. So this length here ends up having to be a fixed length. It has to be between here to there. This angle is decided, it's fixed. There's no other angle that'll work to make angle, angle, side, make a triangle here. And so this side is not included. So we had angle, angle, side, and because the side is outside of those two angles, it's non-included. Making it angle, angle, side. Okay, so we had two angles and a side. That makes it angle, side, angle, angle, side. If we know that two angles and a side match between two different triangles, then we know those two triangles have to be congruent. All right. Continuing on, we've talked a little bit about right triangles already. A right triangle is a triangle that has one 90-degree angle. Okay, so if we draw a picture of that, we're looking at this right here. So there's a right triangle. And so the legs of a right triangle are the two sides that are touching the 90-degree angle. The sides that touch the 90-degree angle. So that means that this is a leg and this is a leg. Okay, so we have two legs, which makes sense because we as people also have two legs. So we have two legs, and then we have the hypotenuse. The hypotenuse is the side across from the right angle. It will always be across from the right angle. So if there's ever a question that's asking about the hypotenuse, you say, I don't know which one it is. It's always, always, always across the triangle. So it's across from the right angle. Okay, so the hypotenuse is across from the right angle. The two legs are next to the right angle, and there are two of them, and there is only one hypotenuse. All right. So what that means is we can use those definitions, because those were just definitions, for our final congruence theorem, our final way to show that two triangles are congruent, which is called hypotenuse leg, or HL for short. So if you know that you have a right triangle, that's a big part of this. It has to be a right triangle. And if you know the hypotenuse and the leg are congruent to the corresponding hypotenuse and leg in another right triangle, again, they both have to be right triangles, then the two triangles are congruent. The triangles are congruent. So let's draw a picture of what that means. So if we come in here and we have ourselves a nice right triangle, and we know that it's a right triangle. Again, we have to know that it's a right triangle if we know the hypotenuse, which is the H, and the side, meaning one of the legs. So hypotenuse, leg, then that is HL, and we can know that the two triangles are congruent. Again, they have to be a right triangle. So if they are not right triangles, then you can't use HL, because only right triangles have a hypotenuse. Okay? So those are our shortcuts that we have. So we'll go ahead and do a couple of examples now to make sure that we can identify and use them. So we're going to look at these and say, are these triangles congruent? And if so, how do we know? So if we look at this, we have a side here and this side here. Those two sides match. Then we have the side on the opposite sides here that are both marked with 3s. Those match. Now, at first look, we might say that these aren't enough. There's only side-side, and side-side is not one of our congruence theorems. But if we look a little closer, we'll realize that this side here is shared between the two, meaning that we actually have side, side, side. And so, yes, we know that those two triangles are congruent, and therefore we know all of the angles are congruent, we know the sides are congruent, and all of that information there. Okay, let's look at the next one. If I look here, I have an angle that matches an angle. They're both right angles. I have a side that matches a side. So right now I have angle, side, and again, I only have two pieces of information. So at first look, this doesn't look like there's enough. But we dig a little bit deeper and we realize, wait a second, there's some vertical angles here. This angle matches that angle. and therefore I have angle, side, angle. And angle, side, angle is one of my congruence theorems, so I can say that those two triangles are congruent. All right, now let's look at this third one here. Again, so I come in here and I look at this. I have opposite sides here, so side, side. And then I look at this angle here. And so I have an angle here, and I have an angle here. So I've got angle, I've got side. And then using what we did on the first one, we could say, okay, I've got this side right here. That side is shared between the two, so that's a side. That must mean that this works. So if I look at this and I go side, side, angle, well, was side, side, angle one of my congruence theorems? And we would say no. No, it was not. The angle is not included. Side, angle, side works, but we don't have that. The angle is not included. It would also not work if it was reversed and we said angle, side, side. That would not work either. Okay? So side, side, angle, or angle, side, side is not a congruence theorem, and it does not work. Does not work. Okay? So this is a no. All right, let's keep going. All right. State whether what additional information would be needed to prove the two triangles congruent. In this case, angle, side, angle. If we look at this, we have an angle here and an angle here. We also have a shared side. So we have angle, side, and we need angle, side, angle. The side has to be between the two angles, meaning that the side that we would have to have would be that this angle, angle DUT, would have to be congruent to this angle here, which would be angle SUT. Okay, so those two triangles would have to be congruent. That is the missing information right there. All right, so let's look at the next one here. We have side, angle, side. Again, we have an angle here. So there's an angle, so we've got that part covered. And we have a shared side here, so side, side. So that's covered. The angle is between the two sides that we care about. So if we look at where is the side missing, it's right here on the opposite side of the angle. So those two sides that I just marked in green would have to be congruent. So XK, segment XK, would have to be congruent to segment VW. Okay, so those two sides I just marked in green would have to be congruent for us to be able to say a side, angle, side. Our final example here is looking at HL. So if we look at this, we know that we have a right triangle. Right? So it's a 90-degree right angle, which is good. It's a right angle. And opposite the right angle, I have a hypotenuse. That's the H. So I would need one of the two L's, meaning I could have this, one of those two L's. So DF would have to be congruent to VX, or, and this one works just as well, or we could have said that DE is congruent to VW. So this is an or one, meaning that we could have chosen either one of those pairs, but if we picked one of those pairs in either case, we would have had HL would have worked. Okay, so we only need one pair, not both, but we do need one of them to be able to show it as HL. So as you can see, there's a lot of shortcuts. They are all very similar. So the hardest part is just keeping them straight and remembering which ones are included and which ones are not included. So again, listing them all together, we had side, 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 angle, side, HL, angle, side, angle, and angle, angle, side. Those are our shortcuts, and those will be what we use to show that two triangles are congruent.